All right. I think we're going to go ahead and get started. Got a nice full room today. So my name is Jeff Mieleff, and I'm a program manager in the Exchange product group at Microsoft. And we're here today to talk about Exchange Server 2013 sizing. Really happy to be here in Madrid. I delivered this session a couple of weeks ago in New Orleans to a very packed room, similar to this. We'll see if we end up having to do a repeat of this session. If you do want to review this content, I don't think we're actually recording these sessions, but there is a recording of the New Orleans delivery of this session available online on the Channel 9 website. So you can certainly go and reference that in the future if you need to and want to kind of revisit some of the things we talked about today. So just a little bit of background on me by way of introduction. I've been with the Exchange Group for about 13 years, and I've worked on performance and scalability of the Exchange product that entire time, basically. I'm currently in a role where I actually work partially on Office 365 and partially on the on-premises product for Exchange Server. So I do a little bit of both, and love coming and talking directly to customers through these events to talk about problems that impact you with your Exchange deployments. So in terms of what we're going to talk about today, I have quite a bit of content to go through. And I'm going to ask that you, if at all possible, hold your questions until the end. I'm going to try and leave enough time for a few questions at the end. If we can't get to all of your questions, I'm going to be at Ask the Experts tomorrow evening. And I highly encourage you to come to Ask the Experts if you have follow-up questions about this or really any other questions about Exchange. There will be many folks from the product group as well as some of our fantastic MVPs on hand to answer those questions. Go work on the whiteboard, figure out deployment scenarios, et cetera. Whatever you want to talk about, we're happy to go through those questions with you. So today we're going to talk through kind of a high-level overview of the sizing process, how to think about building an Exchange Server 2013 deployment for on-premises. We'll go through what's changed in 2013 compared to previous releases, and why have we made some of those changes. What are the significant changes as far as CPU and memory, and what are you getting in return for some of those potential increases in hardware requirements for the 2013 product. And we'll go through those roll by roll. We only have 2 rolls now, so that's a little bit easier. We'll also talk through using the calculator briefly. I'll go through a demo of how to use our role requirements calculator to actually build a sample deployment and model some changes in that deployment to see what the estimated impact of those changes will be. Briefly talk about some other tools and resources available to you for the sizing process, and then, like I said, we'll ideally have time for a few questions at the end. So let's go through the sizing process. So in terms of Exchange sizing, I really love working for the Exchange team. We're thought of as sort of a model of this process for a number of product groups at Microsoft. I love getting calls from other product groups at Microsoft saying, we heard from our customers that Exchange has great sizing guidance. Why don't you have something similar? And they want to know how we do it. That's fantastic. That's the best compliment we could get, right? We've not always been that good, and we've not always had the kind of guidance that we have today available to our customers. But we've been kind of refining the process over the years and over the releases. I've been involved in probably 3 or 4 different iterations of a calculator tool for Exchange. Most of them have failed miserably. Anyone here ever worked with the System Center Capacity Manager tool that we released a few years ago for Exchange? Nobody? Okay, that's probably good. It didn't produce very good results for Exchange. And what we've found over the years is that when you try to get too complex or too detailed in modeling Exchange and sizing Exchange, the results tend to be worthless, essentially. Exchange is a really complex product, and it's really hard to estimate resource requirements for Exchange in a generic way that would work for everyone in this room. So what we've tried to do over the years is get less complex in our guidance and less complex in how we build models and how we build tools, and provide what we think is a good kind of generic estimate with a little bit of wiggle room, a little bit of overhead to account for differences in all of your deployments that should work out of the box for everyone here. That's really what our guidance and what the calculator is providing today. It's not trying to model every little thing in the Exchange product. It's trying to provide the best sort of generic estimate that we can. And I'll talk through how we arrive at those numbers. So we get our sizing guidance primarily from production deployments. We historically have used a lot of test data from our labs to produce this sizing guidance. We've actually kind of moved away from that over the years. Going back to Exchange 2000, a lot of our sizing guidance for 2000 came out of lab tests. And as I look at each release since then, we've really moved more and more to making sure that our guidance is coming directly out of production observations, whether that's Microsoft IT's internal deployment of Exchange, Exchange Dog Food, which is our internal production deployment for the Exchange team on very early builds of the product, or from actual customer deployments through our technology adoption program, rapid deployment program, those types of programs that allow customers early access to our releases, as well as ongoing feedback from the field. You know, we do change our guidance over time if we discover that there are issues with the numbers that we've released. So today, from a 2013 perspective, really all of the guidance that we've provided has come out of production deployments, primarily dog food, as well as a little bit of data from Exchange Online as well. We have a very large deployment of Exchange 2013 in Exchange Online as part of Office 365. And we'll be tuning our guidance over time based on your feedback to us. So in terms of IOPS guidance, storage throughput guidance, that's probably the thing that we're best at measuring. And that really comes from 100% from production data, production observations. And what we do is isolate different profiles of users, different sort of buckets of user types. Very light users, very heavy users, and somewhere in between. We monitor their utilization of the system over time. We draw those points on a line. Hopefully they're linear. If not, then we go figure out what's wrong with our data or what's wrong with our product. And we come up with a formula for predicting IOPS. That's how the calculator and our sizing guidance produces IOPS guidance. We've gotten really good at generating those numbers, and we'll talk through what some of those numbers look like for 2013, because they are a little different in the sizing guidance compared to what we've talked about from sort of a marketing perspective for 2013 previously. One of the nice things in Exchange 2013 that I'm a huge fan of is the fact that we're very data-oriented. We have a component built into the product that's collecting performance data on every Exchange 2013 server. We use this internally for informing this guidance creation process, or this process of creating these sizing numbers. You can also use this data as well. Every Exchange Server 2013 deployment that you do is actually going to be producing perf log files in the directory down there at the bottom of the slide. And we're going to store by default up to 5 gigs of data in that path, basically the most recent perf logs. And it's a set of counters that we typically use internally at Microsoft for understanding the health and performance of an Exchange server. I like this for a number of reasons. Probably the first being the fact that it's always there and we can go reference it if you run into any sort of a problem that Microsoft support has to assist with from a performance perspective. We don't have to necessarily go and ask you to go reproduce the problem with performance monitoring turned on. We actually have logs going back probably about a week in the past, so we can go gather that data and go troubleshoot without having to reproduce the problem. I love that aspect of this. But you can also take this data, load it into a data warehouse. There's tools built into Windows that will allow you to take a perf log file and load it into SQL, as an example. And you can trend how your servers are performing over time. We actually do that internally. We have a giant data warehouse that's actually stored in SQL Azure of all of our internal servers, MSIT servers, dog food servers, as well as Exchange Online servers. And we can go back for months of time and understand for each one of these data points how these servers are trending and make predictions about whether or not we need to add capacity, how we're performing, whether or not there are bugs that have been introduced, et cetera. You can do the same thing fairly easily because this data is already here for you to play with. So highly encourage you to check that out. I mentioned that we don't cover everything in our guidance. We're trying to provide sort of a high-level prediction, not a very specific prediction for your exact scenario in our sizing guidance and in the calculator tool. That means that there are absolutely things that are not included within our guidance. We don't consider every version of every client that can access Exchange. That's very tough for us to do. And there are certainly differences, as an example, in how Outlook 2000, XP, Outlook 2010, Outlook 2013, et cetera, would access Exchange. There are definitely differences in ActiveSync devices and how ActiveSync devices will impact Exchange. Right? There are some ActiveSync stacks that are a little better than others in terms of their impact on the server. We do provide a level of load from an ActiveSync perspective and from an EWS perspective, and really from the perspective of all possible client types in our guidance, because we're actually utilizing Microsoft production data, where we have typically multiple Outlook clients, multiple ActiveSync devices, potentially EWS clients, potentially IMAP clients as well, all accessing mailboxes simultaneously. I know that I personally have probably 5 Outlook clients, 3 ActiveSync devices, a couple of EWS clients, and just for fun, a couple of IMAP clients, because I like to find IMAP bugs in Exchange, active against my mailbox all the time. And these are the types of users that we're using to generate the numbers that go into the sizing guidance. So we have a fair amount of overhead built in, but we don't predict everything. Probably one of the biggest examples of that historically has been the impact of BES, BlackBerry, right? RIM actually provides great guidance, or historically has and continues to do so, around what the impact of a BlackBerry user is on Exchange. And in those cases where we're dealing with third-party products that have a significant impact on Exchange, we highly encourage you to go back to that vendor and get their guidance on how their product impacts Exchange, and then add that into your sizing results. There's a way to do that in the calculator, both from an I/O perspective as well as a CPU perspective. Our partners in the field have a much better idea of how their products impact Exchange than we do, because they test with their products much better in their labs than we do. We're more concerned about functionality, quite frankly, than about the perf impact of those third-party products on Exchange. But our partners are very concerned about performance and generating that sizing guidance. So once again, highly encourage you for those third-party products that you have deployed to go get that scalability and sizing guidance from those vendors and include that in the sizing process. We obviously cannot include the impact from line of business applications. If you have an application that you've written for your business that's going, for example, and accessing Exchange web services to get mailbox data or to send messages, or maybe a CRM application that's storing contacts in mailboxes, we have no way to predict what the impact of that is going to be on Exchange. And some of those can have a very significant impact. In those cases, we actually recommend doing some load testing in your own pre-production environments to understand what that impact looks like, and once again, add that into the sizing process. So just keep in mind that we don't cover everything. If there are things in your deployment that you expect, that your gut tells you are going to have a significant impact, then by all means, take some time, understand what that impact is going to be as you go through this process, wherever possible. This is a slide that I actually created back in February. We had an internal conference for our technical field, and I delivered a session on Exchange 2013 sizing. This is before we actually released our sizing guidance. So it was an hour and a half of me talking about nothing, basically, which was a little bit of a challenge. But really, the key message was what you see up here on this slide. And I think this is relevant even though we have sizing guidance today. If you run into a situation where you don't have sizing guidance, say from a third-party vendor who's producing an application that integrates with Exchange, or a new release of Exchange where we haven't yet released sizing guidance, these are really the key things to keep in mind about how to proceed with a deployment without having that guidance available. The key here is that over-deployment is your friend. Deploying extra hardware generally isn't going to hurt. Obviously, that's costly, not necessarily something that you want to do, but deploying a pilot is usually the best way to start, right? Pick a few users in your organization that you want to get a feel for the new functionality or the application that you're deploying with Exchange that you don't have guidance for. Start small, maybe 5 users, and go and monitor the system. See what that impact is. This is not an easy thing to do. It requires a fair amount of work, but what you're doing is basically monitoring the system and trending how the system behaves as you ramp up utilization. The goal here is to not get to the point where you've overloaded Exchange and you kind of fall off the cliff. You want to be able to have a slow enough ramp that you can predict when you're going to need to either stop deploying more users or add more hardware and grow further. So that's straightforward, fairly obvious, but worth calling out. This is really the best way to consider deploying without actually having guidance in place. So start to finish, high-level overview. It's really 6 steps that we talk about here from a sizing process for Exchange. The first one is really what we're doing here today, understanding what the guidance is. Our guidance changes, so what I'm talking about today and what we have published today could be different in a couple of months. I know I'm involved in a discussion right now around our memory guidance and how that might change in future cumulative updates or service packs for the product. We will be changing it over time, so be aware of that. If you're going to go through this process, deploy more hardware, whatever stage you're at, as you begin this, be aware that the numbers may have changed slightly since the last time you went through the process. Understanding how your existing deployment is performing is really key here. And when we think about user profiles and how we describe utilization within Exchange, what we typically talk about is a user profile that's based on message traffic, message throughput, the number of messages being sent and received per user per day. And we describe those in terms of numbers like 50, 100, 150, et cetera. So the 150 profile means, well, let's use me as an example. If I were sending 50 messages a day on average and receiving 100, 100 plus 50 means that I have the 150 profile. There are a couple of different ways to gather that data. If you're coming from an older version of Exchange, 2007 or earlier, you can use the Exchange Profile Analyzer tool, EPA, and that will actually go and log into all the mailboxes on your server using DAV and gather statistics, including user profile data, that you can then use as an input to this process. We got rid of DAV in Exchange 2010, so EPA doesn't work anymore. And we have not released a replacement tool for EPA. But you can also get this data from message tracking logs. All we're talking about is message throughput here. And we actually have a link in the sizing guidance blog article that's up on the Exchange team blog that points to a PowerShell script that will go through message tracking logs and extract some of this information. And so you can use that for Exchange 2010 or 2013. It's also extremely important to understand your average message size. Average message size is going to help you size transport queue databases. It's going to help you understand log file sizes, and that's going to help you understand network bandwidth requirements if you have a DAG and you're doing log replication. There's a number of ways in which average message size is going to impact the sizing process. So understanding that, really important. That can be found via transport perf counters in your organization. And really all you're looking for is an average across the entire deployment. You're not looking for per user information for average message size. Tools like EPA can give you that data, but that's really not interesting. It's a little too specific. We just want one number for the whole organization. And these typically look like 75 kilobytes, maybe 100 kilobytes, 200 kilobytes. Anyone out here actually know your average message size and have a really big one, like a meg? I've worked with customers whose average message size is 1 megabyte. It makes sizing a little bit challenging. Those are typically customers who do a lot of work with media. So they're sending and receiving video files, maybe large Photoshop files back and forth, and that's their primary use of Exchange. And that's not really typical, but there certainly are customers out there who are doing that today. And we find that the average message size changes over time. It certainly has grown via our own internal collection of performance data in the years that I've been working at Microsoft. We used to look at a less than 50 kilobyte average message size, and we're now up in the 75K to 100K range. And we expect that it will continue to grow as people send more attachments, as clients actually change the way that they format data, moving from, as an example, RTF in Outlook to HTML, dramatically changed the average size of messages. Compressed RTF is really optimized for sending small messages. HTML, not so much. HTML actually bloats the size of a message fairly dramatically. Plain text messages are fantastic if you want small message size. So once you have data on the existing deployment, and that's something good to kind of trend over time to see how it changes, then you need to think about specific constraints, specific business requirements that are very hard for us to predict for your deployments, but you probably know very well. And what I'm talking about there are things like the number of database copies you need in your DAG if you're going to deploy a database availability group. That typically comes from business requirements around high availability and disaster recovery. I have no personal best practice to give to you on the number of copies that you need. There certainly are deployments where 2 copies is sufficient, depending on the type of storage solution you're using. You may be deploying on JBOD and have 3 or 4 copies, or maybe more. You can have up to 16 copies. It really depends on your specific business requirements and what level of high availability you're looking for. Backup requirements also have a huge impact on this. Some customers go backupless. I know in our deployment at Microsoft, we go backupless. That is something that I think we have probably less adoption of than what we would like. There are certainly a lot of customers today in the field who are continuing to use traditional backup methods to back up Exchange. That will impact the sizing process. Storage architecture also has a huge impact. Whether you're deploying on a SAN, shared storage, whether you're deploying on locally attached, direct attached SAS or midline SAS, SATA, et cetera, whether it's rated, whether it's JBOD, that also has an impact here. Safety Net is a new feature in Exchange 2013. It's the sort of evolution of the transport dumpster. And there's a setting on Safety Net for the number of days of data that you want to maintain in that sort of safety net dumpster area. And that setting will dramatically impact the amount of data that we store in transport queues after the messages have actually been delivered. That has a sizing impact. So understanding from a disaster recovery perspective how long you want to keep that data, that's going to have an impact here. Obviously, there's a number of other areas here that have an impact, and this is not exhaustive. Any sort of specific business requirement that you have, you need to understand those up front as you go through this process. So once you've collected all that data, go to the calculator. Can't emphasize enough, using the calculator is the way to do this. We released our sizing guidance for 2013 and described the manual way to go through the process. It is a pain. I would not recommend that anyone go through this process manually. I had to just to go check all the numbers in that blog article. You don't want to do that. You want to use the calculator. And we update the calculator fairly frequently. I'll provide a link to it in a few minutes. So, whenever you go through this process, go to that link, download the latest copy, make sure you're up to date. The calculator is going to provide some options, typically. And those options are usually around different storage types that might work, different different server counts that might work in different ways depending on your high availability requirements. And it allows you to model the differences and the impacts on system failure, or understand the impacts on users as failures occur within the tool. It's actually really powerful to be able to understand that without going and doing a lab test to see how Exchange reacts as different things fail. So use the calculator, go through and kind of model those different behaviors, and make sure that the design that the calculator has provided meets your needs. Then you can go and sort of go through a cycle of iteration there and change the inputs into the calculator to get exactly what you're looking for. And then finalize the design. Save the calculator. Can't emphasize that enough. Save the calculator with the design that you've concluded on. Archive all the documentation that goes along with the design process. Hang on to that. That's really critical if you have issues in the future from a performance perspective or a scalability perspective. For us at Microsoft, who typically deal with escalations from customers around performance, to be able to understand what the goal was as you went through the sizing process, to see how things might have changed over time, and whether or not the system is really performing as it was designed. So hang on to that, archive it. It's very useful data at some point in the future. So let's talk about the more interesting stuff. Changes in Exchange, why we've done what we've done, and what the impact is on the sizing process, on performance, on scalability. So you've probably seen a slide that looks something like this at some point in the last year or so. Sort of the generic high-level architecture of Exchange 2013. From a sizing perspective, there's a couple of key points here. When we went into the design process for 2013, there were a couple of goals that we had that are relevant here. Probably the biggest is that we really wanted to design the product around what we consider balanced use of hardware. What do I mean by that? What I'm referring to is a good balance between CPU utilization, memory utilization, and storage utilization on the cheapest possible hardware that we could find. And by cheap hardware, what I'm referring to is commodity hardware, 2-socket servers, storage built into the box, JBOD, very simple hardware, very easy to obtain, very inexpensive for us. And that's the type of hardware that we deploy in Exchange Online to try and lower our costs as much as we possibly can. And ideally, we would love to see as many of our customers with on-premises deployments deploy that same type of hardware as well, because it's very well aligned with how we thought about the architecture of the product going through the development cycle. We think that particular type of hardware actually results in a really good balance between the available CPU horsepower, the available memory expansion capacity on those platforms, and the number of drives that you can fit typically in a 2U server chassis. There are certainly going to be reasons for not deploying on that type of hardware. I've worked with a number of customers directly since we released 2013, and probably half of them have gone with what I'm talking about, and the other half have gone with either more traditional Exchange architectures that might involve shared storage or SAN, or have expanded the storage via additional external storage chassis in some way. There's certainly many options. We support many options in terms of the hardware that we deploy on, but the hardware that I described was what we were thinking about when we architected the product. That's the key thing to keep in mind. The mailbox role is really a consolidation of mailbox, CAS, and hub from 2010. Very similar to a multi-role deployment of 2010, which we really advocated as a best practice for the 2010 product to simplify the deployment process and actually get a better utilization of hardware. Very similar to the mailbox role in 2013. The CAS role is actually kind of a net new addition in 2013. Nothing to do with the CAS role in 2010. Totally new in 2013, and it's really just a stateless proxy. It's not doing a heck of a lot. Hopefully a number of you went to the CAS session yesterday and got a little more insight into the technical details of what CAS is doing today. It's really not a very busy server. And as we'll talk about in a few minutes, we're actually going to advocate as a best practice co-locating CAS and Mailbox, doing a multi-role deployment in 2013, kind of in the same way that we did on 2010. It simplifies deployment. There's very few reasons not to do it. And we think that you actually get some great high availability benefits by essentially having more CAS servers and through that multi-role deployment method. And there's really 3 roles that you need to think about for sizing: Mailbox, CAS, and our good friend Active Directory. Exchange is really dependent on AD. Has been since 2000, and will continue to be so for the foreseeable future. You need to make sure that Active Directory is sized appropriately. I'll talk through what the guidance is. It really hasn't changed since 2010, but if you don't have enough Active Directory horsepower in your deployment, your users will feel it. Exchange does a pretty good job today of trying to hide Active Directory query latency behind the scenes, but there's only so much we can do. You've got to have enough AD horsepower to meet those demands. So minimum requirements have definitely changed in the product. Anyone here tried to deploy 2013 on a virtual machine just for testing with like 2 gigs of RAM? Yeah, had a little bit of a painful experience, I'm guessing. Yeah, it doesn't work very well. So the minimum memory requirements have definitely increased in 2013. So for Mailbox or multi-role, we require a minimum of 8 gigs of RAM. And for the CAS role by itself, a minimum of 4 gigs of RAM. You can get away with a little bit less than this if you're just building a test lab. Like if you want to build a VM on your laptop to try things out, you can probably drop that Mailbox or multi-role down to 6 gigs. You'd probably be okay doing that. But for production use, these are the absolute minimums. And these numbers go up pretty dramatically when you think about actually sizing for performance. I'll talk through what those numbers look like in a minute. We've also dramatically increased the disk space requirement for the install directory. This is something to keep in mind. I know there's many people today who are installing Exchange on a system drive. Maybe they're virtualized and they're using like a master image with differencing disks for the system drives, as an example. This is going to probably have a dramatic impact on the overall storage utilization of those drives. So we've moved up to a 30 gig minimum disk space requirement for the install directory. And the reason for that is really all the additional logging and tracing that's enabled by default in the product to try and make the product easier to diagnose, easier to debug, and also enable some of the performance logging features that I mentioned earlier. The perf logging is really only about 5, maybe 6 gigs of this. The rest of it is around additional logging for other components. But just be aware that directory is going to grow pretty dramatically. And even on a server that you don't think is doing anything, you're going to see activity because of managed availability. On a server that is not doing anything from a client perspective, Exchange in the background is going to be logging into mailboxes, running various transactions to make sure that things are up and running, and that's going to result in logging, tracing, stuff happening on the server, and getting logged in these directories. So don't be surprised when you see these directories growing. Don't freak out. That's what's going on, and it's expected. So just plan for that 30 gigs. So the new Mailbox role, we're going to spend a few minutes just focusing on Mailbox. So I mentioned that we really were thinking about balanced utilization of hardware when we architected the Mailbox role. There's a few other things that we were thinking about as well. Deployment is obviously simplified if you just have one major role compared to what we had in 2010 with Mailbox, CAS, and Hub. You really only have to think about just one thing to install and one thing to scale as you deploy more servers. From a cache effectiveness perspective, this is actually kind of a nice performance benefit. So as you've probably heard said many times as we've talked about 2013, the server responsible for handling a request for a user is the server that has the active copy of that user's mailbox database, right? That enables a number of wonderful things in the Exchange 2013 architecture, but it also means from a performance perspective, we no longer have 10 or 15 servers that are all responsible for handling activity related to a particular user. We really only have one server. And that means that all the internal caches within Exchange that cache data to prevent us from having to go to disk or to Active Directory or to other servers in the deployment, we can make much better utilization of those caches because all of the activity for a particular user and all of their requests will be localized to that particular server. Actually has a fairly significant impact. So we're really happy with that, that effect of the architecture change. There are definitely some considerations around the mailbox role from a sizing perspective. We are increasing resource utilization. We're increasing memory requirements. We're increasing CPU requirements. We're reducing I/O requirements, and that's one of the benefits that you get as a side effect of some of those CPU and memory increases. But there are changes there that you need to be aware of. The process of sizing database cache is totally different than what it was before. We used to use virtually all the memory on a mailbox server for database cache. We're not doing that anymore. The other processes on a mailbox server in 2013 use a fair amount of memory. And so we need to leave a lot of memory on the table once the Exchange store processes start up so that those other processes on the server can take advantage of that available memory. So instead of sizing for 80% of RAM, as we might have done previously, we're now only sizing for 25% of RAM for the database cache. Everything on the box, on the mailbox server, is constantly interacting with each other. There's many, many processes running on a mailbox role, with one process per mailbox database, and all the processes that were added as part of the new features and functionality in the product. We have a lot of stuff going on mailbox. And we also have a new component called workload management that's running in the background and kind of trying to mediate that and make sure that we are optimizing for end user experience wherever possible. That's something that historically you might have thought about a Windows component like Windows System Resource Manager doing and trying to mediate between the needs of different processes. We've actually built that type of process into the product, baked it in, much like we took some of the functionality that might have been in the SCOM management pack in previous releases and baked it into to Exchange in managed availability. Workload management is always going to be there behind the scenes trying to mediate the impacts of the needs on the system. So just be aware of that. Managed availability definitely has an impact on the system. And it's included in the sizing guidance. You don't have to go size for it. But it's responsible for some of the increases that we're talking about. It has CPU requirements since it's constantly going and logging into mailboxes, running transactions, trying to make sure that it's able to respond as quickly as possible to any sort of an outage on the system. There's going to be an impact to that, right? You're paying in terms of a CPU cost for that additional high availability that's built into the system. So that's one of the things that you're paying for, but you get some significant benefit out of managed availability. Highly encourage you to take a look at the managed availability content that's part of TechEd, so you understand better what that actually refers to, what you're getting out of that. It's some very, very cool technology. The new CI architecture also has a pretty dramatic impact on performance. So we replaced MS Search, our old CI infrastructure, with Fast. Fast is a product that we bought a couple of years ago, initially integrated into SharePoint, and in 2013 integrated into Exchange. It's good for a number of reasons. MS Search was sort of a dead-end search infrastructure. Have any of you had the experience of having MS Search problems and calling into Microsoft support and trying to get them resolved? Not an easy process. We didn't have a lot of development resources that really knew what was going on with MS Search to try and resolve those problems because it was a dead-end product. Fast is actually actively maintained. We have a fairly large development team directly working on Fast, and it provides us the ability to actually innovate on that platform and build new features like the integration of search across SharePoint and Exchange for things like e-discovery. Fast enables that. It also is fast. It's a fairly performant query processor and search engine, but it uses a fair amount of memory in order to be able to deliver those features. So compared to what we looked at in 2010, we are definitely seeing an impact on system resources from the new CI infrastructure. And we'll talk about the impact of unified messaging in a few minutes. So around storage capacity, this is really the first thing that you typically size for. In general, the process of sizing for storage capacity is very similar to 2010. You're really looking at the size of mailbox data on disk, the size of log files, and the needs for content indexing. So historically, we've had a 20% database overhead value that you had to add on in the sizing process. And that was really the number that we used to account for the difference between what you saw in Get Mailbox statistics for the size of an individual mailbox and the actual amount of space that it took on disk. It was around 20%. So we told you to add 20% to your sizing process to account for that. That number is now 0. We're actually doing a much better job compressing data on disk in 2013 than we ever have, and that allows us to remove that line item from the sizing process. That's fantastic. Now I'm going to take it away from you. So CI is actually using more space than it did in 2010. So in 2013, CI is now going to use 20% of the EDB size, the mailbox database size, for its index files. Additionally, it's going to use another 20% for basically temporary space for what we call the master merge process. Think of it as background maintenance for CI. Every so often, CI will go through and create a new set of indexes that are optimized, and we need that additional space to be able to do that, to go through that process. So if you have a single database on a volume, that means that you're sizing for basically 40% of the EDB file for CI. That's pretty dramatic. But if you have multiple databases per volume, which is something that we're advocating as potentially a best practice in 2013, depending on your requirements, that additional index set is really per volume. It's not per database. So the impact of that additional space for master merge is much lower on a percentage basis if you have, say, 4 databases per volume. You would size for 20% of each one of those 4 databases, and then you'd only need one set of basically an additional 20% rather than doubling everything. You just double one of those database sizes, one of those index sizes, I should say. And that's all you need for that type of deployment. The reason being, on a particular volume, we'll only do master merge for one database at a time. So that is a very good reason for considering multiple databases per volume. Significantly reduces your storage requirements. We also had a maximum of 50 databases per mailbox server in the released version of Exchange 2013. We announced at TechEd in North America a couple of weeks ago that we will be increasing that back to 100 in Cumulative Update 2. That was kind of a blocker for a number of larger, high-scale deployments. In general, this is not something super interesting to a lot of customers, but if you are in that sort of 100,000, maybe 200,000 user deployment range, this may be something that helps you fairly dramatically in terms of how you design your deployment. So we have reduced the IOPS requirements in the product. We talked when we released 2013 about a 50% reduction in I/O. And we definitely see a 50% reduction in I/O in our lab tests. But as I mentioned at the start, sizing guidance comes from production. We want to make sure that our sizing guidance is going to be what you actually see in your production deployments. What we currently see in our production deployments is about a 33% reduction. So that's what our sizing guidance refers to. You may see something higher than that, depending on the specific workload that you're running in your deployment. But for the initial sizing process, for designing for peak load, for worst case scenario, 33% is the number. So we've continued to reduce these numbers going back to 2003 and earlier. And my guess is we'll continue to reduce them in future releases, though I don't know how far we can go. Eventually we'll get really close to 0, but that obviously is not feasible. We do have to do some I/O at some point. But the other thing that we've done in this area is make the sizing process a little less complex. So in 2010, we actually had different I/O requirements for databases that were associated with a DAG versus standalone databases. The difference there was really around checkpoint depth. If you had a database that was part of a DAG, the checkpoint depth was higher. Checkpoint depth refers basically to the, you can think of it as the amount of data that's allowed to sit in memory that hasn't, or sit in uncommitted logs that has not been written out to the database. We had a larger checkpoint depth for high availability DAG databases and a smaller checkpoint depth for standalone databases. The checkpoint depth is actually consistent for all databases in 2013, so we only have one IOPS number across the board for active databases, passive databases, standalone databases. It's all the same. Makes it a lot simpler. Briefly, don't want to spend much time on this, but just so you're aware, if you have a shared storage deployment where you are using a SAN, maybe iSCSI, and you have a number of Exchange databases using the same storage infrastructure, whether that's the connectivity infrastructure, the storage network, or the storage frame itself. We have run into issues historically where storage bandwidth has become a problem. In Exchange 2010, we introduced something called background database maintenance that's constantly performing I/O against databases, basically to make sure that that all the data on those databases is usable, consistent, validating checksums, making sure everything's good to go. We ran at a rate of about 5 megs per second per DB copy in 2010. And that could, in some cases, overwhelm some of that storage network infrastructure. We've reduced that to 1 meg per second per database copy in 2013. So we're better here, but this is something to be aware of that you may need to consider in your deployment. And the calculator can do some estimates of what that impact looks like. I'm really happy that we actually have some guidance around transport for a change. We didn't provide good guidance in 2010 around what transport requirements looked like, and we realized we needed to fix that. So in 2013, we're being a little more proactive about talking about transport. So when you think about sizing for transport, it's really about the Q database and the impact of safety net. Safety net, as I mentioned, is the evolution of the transport dumpster in 2013. And as message traffic is flowing through Exchange, you can think of those messages as being persisted somewhat temporarily in queue until they're actually delivered to the target mailboxes, but then also hanging around in that same database for whatever that period of time is that you have set for safety net. Additionally, we also have high availability built into transport. So in transport in 2013, we will actually persist multiple copies of a message on multiple transport components of mailbox server. And if you have multiple sites, if you stretch your DAGs across multiple sites, we will actually deliver to the alternate site as a storage copy in addition to the local site, so that if you run into a disaster recovery scenario, we actually have copies of that mail in the alternate site that can be redelivered automatically if necessary. But that has a storage impact, right? We're keeping multiple copies of this data all over the place in order to provide disaster recovery. So in order to size for that, we actually have a process in the calculator and a manual process described on the blog that will actually predict how big that Q database needs to be given your number of users, your user profiles, your average message size, and your days of data in safety net. We can predict that pretty accurately. So that will give you the amount of storage space that you need for the Q database. And then the other thing you need to consider is I/O impact. In Exchange 2007, we released a white paper that said something along the lines of 17 I/Os per message for, I think, a 75 kilobyte average message. which is ridiculously high. And we didn't say anything about 2010. So a lot of people sized for 2010 using that 17 IOPS number. 2010 was definitely lower than 17 IOPS. 2013 is about 1 database IOP per message. It's actually a little bit less if you have a fair amount of message flow running through your system per 75 kilobyte message. And we're actually going to provide some more guidance in this area that describes how that number changes as the message size changes. But the key thing to note here is that because that number is really low, because we're only looking at about 1 I/O per message, we think that as a best practice, most customers are going to be able to deploy their transport databases on their system drive, or basically in the Exchange install path that's typically on the system drive, rather than having to dedicate storage specifically for transport. That's how we do it internally for Exchange Online and in our own MSIT deployment, and it works great. The key thing to remember here is that we recommend deploying with a protected write cache disk controller. That means like a battery-backed disk controller or something with flash memory on it, so that if you have a power outage, you're not going to lose cache. If you do that, the vast majority of the I/O that's running through that system is effectively free. It's a lot of log I/O that's going to result in a few database I/Os here and there, but that log I/O becomes pretty much free if you have a disk controller with some good write cache in it. So that's the recommendation there. You may notice that that you run into throughput bottlenecks if you don't have a disk controller with write cache available. So definitely a best practice there. And you'll notice that the 2013 role requirements calculator will actually tell you whether or not it's feasible to put the transport database on the system drive, based on some observations about the type of storage you're using for your system drives, the type of disk, as well as size requirements. So processor requirements, as I mentioned, have definitely increased. If you go and kind of look at just the numbers and compare them to what the numbers were that we published for 2010, you'll notice that they're pretty close. The second column there, the megacycles per user for active database or standalone copies, I think in 2010 goes something like 2, 4, 6, 8, 10. So this is just a little bit more than 2010. The problem, though, is that the baseline platform that we used for measuring these numbers changed between the two versions. So you can't just look at these numbers. You actually have to go through that normalization process that we describe in the blog of figuring out what the benchmark data looks like for the particular server platform that you're deploying on and how that differs from the platform we used for our measurements, and then adjust these numbers appropriately. What you'll find is probably somewhere around maybe a little bit less than a 2x increase in CPU requirements for 2013. Some people have gone and looked at the calculator for 2010 and the calculator for 2013 and waved their hands and said, oh my God, it's a 5x increase. That's not true. We're not looking at a 5x increase. You can't compare the output of the 2010 calculator to the 2013 calculator. Be aware of that. The 2010 calculator is only predicting CPU for mailbox. It's not looking at the CAS components or the hub components, even when you select multi-role. So the numbers are not directly comparable. Just be aware of that. Don't freak out if you try and make that comparison. You need to actually do a little more work if you want to directly compare. And that additional work really means going through and figuring out what the overall design would look like from a hardware perspective for 2010 and 2013 and compare the costs there. Don't just look at the calculator. Oh, one other point. We did actually have in 2010 what we called a per passive multiplier. So that was an additional amount of CPU for every active copy that was based on the number of passive copies associated with the active copy. It was an additional percentage on top of it, and it could be a fairly dramatic increase if you had like a 3, 4, 5 copy DAG in your deployments. We've removed that. That additional per passive resource requirement is actually included in these numbers. We don't see a need to actually add that in, and that's another reason that it's hard to compare between 2010 and 2013 from a CPU perspective. So thinking about hyperthreading, we do recommend absolutely turning off hyperthreading in 2013, and we have a good reason for it this time. We recommended it in 2010, and it was sort of wishy-washy. The reason described for 2010 was really about capacity planning and trending, and didn't really have hard evidence behind it in terms of why we didn't recommend having hyperthreading turned on. In 2013, we've done a fair amount of work internally to see what the benefit looks like. We see about a 20% throughput increase from a CPU perspective. The problem is we see a dramatic increase in memory utilization. And that actually comes from the way the .NET framework works. And without going into too much detail, I'm happy to go into as much detail as you want on this if you want to ask me questions afterwards. Basically, there's two different ways .NET will allocate memory for processes. And that depends on whether those processes are designated as workstation processes or server processes. If they're server processes, .NET will go and allocate heaps, basically areas of memory that are sort of pre-allocated for performance reasons on a per logical CPU basis. So if I turn on hyperthreading, I have doubled the number of logical CPUs visible on my system, which means probably the easiest way to think about this is that if I just go and start up all of the Exchange processes on a server that's not doing anything, the base memory requirement has the potential to double on that server that's not doing anything if I enable hyperthreading. So I get a potentially 20% CPU benefit, but I also have the potential to double my memory requirement and not leave a lot of memory on the table available for Exchange to deal with worst-case scenario failure situations. So that's why we're absolutely recommending turning off hyperthreading in 2013. We will continue to do some work in this area to change processes from being marked as server processes to workstation processes where we can. We've done some of that already, and we'll continue to make progress there. But hyperthreading should be turned off as a best practice for 2013. This is actually some very new guidance. Came out literally the day before. Well, we decided to talk about this literally the day before I delivered this session at TechEd North America. There's an available hotfix for .NET that we're recommending customers deploy on every Exchange 2013 mailbox server. It actually has the potential to reduce the memory consumption of each store worker process. Remember, there's one of those per database on every mailbox server by about 200 megs. It's pretty significant, especially when you consider that you can have up to 100 databases on a cumulative update 2 server. So for customers that are deploying large numbers of databases per mailbox server, I really think of this as an absolute necessity. We're not actually calling it out as a prereq, because at the moment you have to call Microsoft support to get this. It's not available for download to everyone. We hope that it will be soon, but at the moment it's not. But if you go to the links mentioned here, and you will be able to get this deck as a download from the TechEd site. If you go to those links, you'll see instructions for how to obtain those hotfixes. Highly recommended. You have to install the hotfix as well as set the reg key listed here, and that will provide that memory reduction. So in terms of memory requirements, we really provide memory requirements based on database cache. So database cache is sized, like I mentioned, based on 25% of the available memory on the system. And the cache requirements have really stayed static from 2010 to 2013. So what you're looking at here is basically the 2010 cache requirements multiplied by 4 in order to get us that 25% utilization of memory for cache in 2013. So the cache requirement for the 50 profile would have been 3 megabytes in 2010. So we require 12 megabytes of available system memory for that user in 2013, so that we still have that 3 megs of cache memory for that user in this version of the product. That's where those numbers come from. They do look like a dramatic increase, but this is not the cache requirement. This is the overall requirement on the box, and it takes into account additional memory for all the added processes in 2013 that are adding features, as well as the additional memory requirements around content indexing that I mentioned previously. Those are really the two major things impacting memory increase. Around multi-role, I'm not going to go into detail on the formula. There's a formula for figuring out how much memory you need to add for CAS if you're deploying multi-role. It's basically looking at it's based on the number of active mailbox CPU cores in worst case failure, given that CAS requires 2 gigs of memory base plus 2 gigs for every active core. That's how CAS memory is sized. This formula lets you figure out what that looks like for a multi-role server. And we do have some minimums as well. Those generally are not going to apply, but if you're in the scenario where for some reason you have a single user per database, maybe you're a Notes user and you like that model, everybody gets their own database, then minimums might matter for you. So just be aware that they're there. The calculator will take minimums into account when you go through that. Around networking, nothing's really changed around our requirements here, other than to point out that 10 gig is definitely becoming more commonplace for Exchange. And as you think about Exchange deployments and sort of our model of having a redundant array of inexpensive servers, you may actually be able to consider like a single network interface per server rather than deploying multiple network interfaces per server, and just letting Exchange handle those network failures, right? Letting an Exchange server failover, essentially, occur if you have a network failure on a single interface. Could potentially reduce the costs of your network infrastructure pretty dramatically. Obviously, you need to make sure that you have enough copies, enough servers to be able to handle that load, but it is something that may work for you. And then UM. So nothing has really changed around UM sizing either. We had a 100 call concurrent limit in 2010. We have the same limit in 2013. Voicemail transcription was a heavy consumer of CPU in 2010, and it is in 2013. And it takes about 1 core of CPU per message that's being transcribed simultaneously. The challenge in 2013 is that UM is installed on every mailbox server. And when you think about this concurrency model, what it means is that if you're a heavy user of UM, you now need to consider how your users are going to be spread out across servers to make sure that you don't run into this 100 call limit. You don't want all of your heavy UM users to be clustered on a single server, right? You want them to be spread out as much as possible. It makes the sizing process for UM a little tougher, potentially a lot tougher. Be aware that if you are heavy users of voicemail transcription, that 1 CPU core per concurrent transcription requirement will result in UM actually skipping the process of doing a transcription if it doesn't see that there's at least that 1 core worth of available CPU when it tries to do it. It'll just send the voicemail message as the sound file and not do the speech to text. So if if that's an issue in your deployment, consider increasing the available CPU there. So real quickly, CAS role. CAS role, very simple, stateless. Doesn't have a lot of resource requirements. Provides some load balancing optimizations. You could think of CAS as doing some of the work that your layer 7 load balancer did in 2010 in terms of figuring out which mailbox server should be receiving load, rather than having your load balancer manage affinity or state, basically, for incoming connections. So CAS, just as it was in 2010, is sized based on a percentage of mailbox CPU. So it was 75% in 2010. It's now 25% in 2013. I'm willing to bet that that will continue to go lower. We actually wanted it to be a little bit lower when we released, but didn't quite get as far as we wanted to go from an optimization perspective. But at the moment, it's 25%. And the sizing guidance talks through how to figure out exactly what that requirement is. We do want to call out that because it's so much lower, for some small customers, you may actually need to consider high availability requirements rather than CPU requirements when determining how many CAS servers to deploy. In other words, the guidance may say you only need 1 server, but obviously you need more than 1 if you care about HA. So just keep that in mind. I already actually mentioned the 2 gigs plus 2 gigs per core for memory. That's actually the same memory requirement that we had in 2010. Because you're going to have fewer CAS servers, the overall amount of memory that you're deploying for CAS is going to be less. But on a per server basis, it's effectively the same as it was. So I mentioned we talked briefly about multi-role. I think there's two reasons not to multi-role. In other words, combine CAS and mailbox. Two reasons. There are some customers out there who work with certificate providers who charge for certs on a per server basis. Basically, they provide an installation package for a certificate that can only be utilized on some number of servers, and you have to pay more if you want to be able to deploy that cert on more servers. If you're in that situation, deploying multi-role might add some cost, right? Because you're going to have more CAS servers, essentially, if you deploy multi-role than you would if you just deployed CAS on its own. I would argue that that's probably a good reason to go find another cert provider if you're in that situation, because you probably get a lot more benefit of multi-role compared to potential cost savings with that model of buying certificates. The other reason is if you want to use Windows Network Load Balancing. We've been advocating not using Windows NLB for a long time. We're going to continue to do so. But you can't use Windows NLB if you multi-role in 2013 because of an incompatibility between Windows NLB and the Windows cluster service that's installed on the mailbox role. So just be aware of that. Those are really the only two good reasons that we've been able to come up with for not multi-rolling. So I'm willing to bet that for those of you in the room, the vast majority of you are not going to be in one of those situations. So multi-role. It simplifies things. You get better high availability, get a better overall experience with the product. Absolutely the way to go. AD hasn't changed from a guidance perspective. 1 AD core for every 8 mailbox cores. The calculator will size for that and show you what that looks like. So let's real briefly, I'm going to spend about 2 minutes talking about the calculator, and then we'll get into some questions. So the role requirements calculator is really a best practice for Exchange. This is the way you should be going through the sizing process. Don't try, like I said, don't try and do it manually. It's a real pain to do this manually. The calculator is fantastic. And it allows you to model different scenarios and understand what the impact of those changes on your environment might be. So let's look at what that looks like for a sample, fairly small deployment. See if my password works. So the calculator is actually distributed as an Excel file, which is nice. You can use the Excel file to save and upload it to SharePoint, track changes, etc. Use co-authoring. All the functionality that's built into Excel is available to you. I'm going to use my nice little laptop here for zoom in, zoom out. So the calculator consists of a tab that comes up as the default tab, the input tab, where you input most of the information about your deployment. The information that comes up out of the box, probably not relevant to the vast majority of you. It comes up with a 100,000 user deployment, site resilient, using 8 DAGs of 8 servers each. That's kind of ridiculous for most people. So what we're going to talk about today is a very quick example of a 10,000 user deployment with 1 DAG and 1 site, no site resilience. So I'll go ahead and make a couple of changes here real quick. So number of database availability groups, I'm going to change to 1. I know for a fact I'm not going to need 8 servers, so I'm just going to change that to 4 here, and we'll see what the impact is. I'm not going to do site resilience, so I'm going to change site resilient deployment to no. And I'm going to use 4 database copies. So I've got my number of copies here. I'm going to leave most of the things in the spreadsheet set to default, but I'm going to change the number of mailboxes to 10,000. And those users, I know, have a profile of 100, not the 200 profile. So I'll go ahead and input the 100 profile. I want my users to have 1 gig mailboxes rather than the default, which is a 10 gig mailbox size. So I'll put in 1 gig. And you'll notice there's a 75 kilobyte average message size as the default here, and we'll just leave that as the default. I do want a multi-role deployment, and that's one of the selections here at the top. It's actually set to yes by default because we are recommending that as a best practice, and I'm not going to virtualize. So in addition, I can set the type of storage I want to use. I'm going to use 4 terabyte midline SAS drives because they're cheap. We love them. They store lots of data at a very nice price point. And I know that the hardware that I'm using has a benchmark rating of 540. There's a tool that I'll point you to in just a second that you can use to get that number. So from there, I can tell you already, I have a problem. So this yellow box here tells me that this particular disk type for my database volumes is insufficient. And because it's looking at the disk type and not the capacity, I don't have enough IOPS available on those drives to meet my requirements. I can also go into the Role Requirements tab and zoom in a little bit so you can actually see this. Windows 8 is great for this, by the way, with the pinch to zoom. If I scroll down, I can see some cells that are highlighted in red. This is telling me that in a worst-case failure scenario, my server CPU is going to be running at 104%. That doesn't work very well. So I know that I am undersized from a number of servers perspective. So if I go back to the Input tab, change my number of servers per DAG to 6, let's see what that does. So from a disk perspective, I no longer have that yellow box, so I know that I'm good on those drives now. From a role requirements perspective, I can see that I'm now at 63% predicted CPU utilization in a worst-case failure scenario. So I'm now good on CPU as well. What I can also do, now that I know that I'm basically good on hardware, I do know, because I've done this a few times, this demo, that I am good across the board for CPU and storage. I can see that the recommended RAM configuration for my servers is 96 gigs. I can see that it's recommending that I place my transport database on the system drive. I mentioned that's an option and potentially a best practice for most customers in 2013. One thing that I do want to point out that most people aren't aware of, all of the stuff that's happening behind the scenes in the role requirements calculator is fairly easily accessible. So each one of the panes, or each one of the sheets in the spreadsheet, has this calculations pane section that's hidden by default. But you can go and expand it and actually see all of the calculations that are being done behind the scenes and what the values are that the calculator is using to make its decisions. It's a huge amount of information that's actually exposed in that area. I do want to point out real quickly a couple of other minor features here. In the activation scenarios tab, you can actually see how many active mailboxes per server will run in different failure scenarios. So this is showing that in a normal runtime, I'm going to have 10 databases consisting of about 1,600 users per server. And after I experience my first server failure, I'm designing for 2 server failures here, by the way. That's what we do by default. I'll have 12 active databases per server, 2,000 active mailboxes per server, et cetera. And I can actually model that. I have a distribution tab that takes a second to calculate, but it will show me here in just a second how those database copies are going to be spread out and what happens if I fail individual servers. So if I fail this server, as an example, it will relocate active copies to the other servers and show you how that changes over time. So I can fail and recover servers and actually export PowerShell scripts to create those databases for me, which is a very cool feature. Makes the process of setting up an Exchange deployment a lot quicker. I can also go in here and look at volume requirements. This is one of my favorite areas. So I'm actually deploying, in this scenario, 4 databases per volume. So database copies 1 through 4 are on a volume, and they're going to be using about a terabyte of space. I have 4 terabyte drives. So by looking at this, I know that I can go probably double, triple my mailbox sizes and still be fine from a sizing perspective. And I could go back and do that right now, model it, and see what problems I run into. So very, very powerful tool. Highly recommend that you spend some time in the calculator if you haven't already. So if you haven't seen the available blog post that describes the sizing guidance in detail and the calculations that are actually behind the calculator, there's your link. It's a fairly long read. I apologize for that, but it's kind of a complex process that needed some description. So there it is. We do have a tool available for getting that SpecInt benchmark number for particular hardware platforms. Fantastic tool for making this process very easy. JetStress is available for Exchange 2013. Highly recommend you use that for every Exchange deployment. There's a few new benefits, new features in the product. And LoadGen. We will be releasing a new version of LoadGen for 2013 later this year. I have some developers back in Redmond right now working on some last-minute tweaks to the tool. So that will be available if you want to do pre-production testing in your own lab environment, understand how Exchange works in particular scenarios with simulated client load. And we'll announce that on the Exchange team blog. So with that, a couple items of related content. I know the transport architecture session isn't being presented here, but it is available on Channel 9 as a recording from TechEd North America. Highly recommend checking that out, get some details on safety net and how that works under the covers. And as I mentioned, I will be at Ask the Experts tomorrow night if you have any questions that we can't cover here. So with that, I will thank you and take any questions you have.